In this video, we will look at the microstructure evolution during solidification. So first, let us take an example and draw the phase diagram for a copper nickel alloy. So this is copper nickel alloy. Okay, so this is the phase diagram. Here you have liquid, here you have solid, and here you have liquid plus solid. Okay, so this is 100% nickel, and here it is 0% nickel. Okay, so x-axis you have weight percentage of nickel. So let us look at what happens to the liquid to solid. For example, let us draw a line like this. Let us draw a line like this for a particular composition. Okay, for a particular composition. So the change is from liquid to liquid plus alpha to solid. So this is what happens. So what happens to the microstructure? So let us take the points like this. Let us look at the points here, 1, and let it the point here be 2, and let the point here be 3. Okay, these are the 3 points. So at 1, so you know that from the phase diagram, we can see that there is only one phase present, that is the liquid phase. So you can see that there is completely liquid. This is liquid. So, what happens when it crosses the liquidus line? So, this is the liquidus line, and this is the solidus line. Okay. Okay. When it crosses the liquidus line and reaches 2, that means when it crosses the solid line, so that means there is liquid here. So, you can see that a single phase crystals forms here. Okay, see, these are the alpha crystals here. Okay, so alpha crystals form at the various point. Okay, so that means if you move down to the solidus, more and more alpha forms, and finally at 3, you can see that it. So you will get a complete alpha like this. It will be fully a polycrystalline material. You can have there are different phases. Okay, so this is a polycrystalline material. Polycrystalline alloy. Okay, so this is an alloy. So this is the microstructure change that is occurring. Now, so let us look at the change in composition. Okay, so for that, during let us look at the change in composition during the solidification. For that, to make it much more clear, here. mm, So, so whenever this crosses the liquidus line, you can see that you need to draw a tie line here. Okay. So, and you select another point here, you can draw the tie line here. You can find for another point, we will draw another tie line. So finally, when it touches the shoulders line, we will draw the tie line here. Okay. So based upon this tie line, we can find the composition of the various phases present and also the relative amounts of the phases. For example, first point, let us take it to be, so here, let it be P. Now this is Q and this is R. Okay. P, Q, R. Yes. So these are the various points. Okay. So at point P, what are the phases present and what is the so at P? So that means at P. the solid is about to form in the liquid. It is completely liquid, but the solid is about to form. So if you take a line just below it, okay, if you take a just below it, you can see that, and if you use the lever rule, you can see that the percentage of liquid is 100 percentage liquid and 0 percentage alpha. But if you take a point Q here, you can see that here, uh, so this will give you the fraction of liquid, okay, and this will give you the fraction of alpha. This will give you the fraction of liquid. Okay, you can see that the fraction of alpha is gradually increasing. So as you go down, you can see that this is the fraction of alpha here, and this is the fraction of alpha here. So this is the fraction of alpha here. So at the point S, you can see that the fraction of liquid is 0. Okay, so it is PQ, so it is PQRS. Here, when it reaches here, it is 100 percentage alpha and 0 percentage liquid. And maybe at Q, just assuming that it will be around 80 percentage liquid and 20 percentage alpha. And here it will be 20 percentage liquid and 80 percentage alpha. Okay, this is how the composition is changing. Okay, now, so what is the, so let us take the point S. Okay. So what is the composition of the alpha that is forming at this point? Okay. To find the composition of alpha, so, it is better to take R. What is the composition of alpha that is forming? So if you find the composition of alpha, first uh, we will draw the timeline. Okay, we will draw the timeline. Okay, so you can find the relative amounts of phases, and also the composition of alpha will be given by uh, this point. So here, this solid means it is alpha. Okay, so this will give you the composition of alpha, and when it touches the liquidus line, this will give you the composition of liquid. So at point out, I am assuming that if this may be 60 percentage nickel, and this may be 20 percentage nickel. Okay. So 60 and 20. So R, you can say that it is 60 percentage nickel and 20 percentage, remaining 40 percentage copper. Okay. So that is the, here the, it is the uh, fraction of alpha. Okay. This is alpha, and fraction of liquid will be equal to some 20 percentage in nickel and remaining 80 percentage copper. So this is how you find the composition of the phases using the tie line rule. And this is how the microstructure evolves. And when it evolves, you will be able to find the percentage, the composition of the alpha that is forming each time.